Alexa, turn on smart clock.
Turned on the switch.
Alexa, turn off smart clock.
Turned off the switch.
Hello everybody! Are you curious to see how I built this? This is part 2 of a multi-part video series on how I replace Amazon Alexa and Google Home in my smart home with a local voice assistant based upon ESPHome and Home Assistant. If you haven't watched part 1 of this video series where I explain how I built the prototype of the local voice assistant, which is the foundation of what we will do today, then I strongly recommend watching part 1 first. I will link it above. This part of the video series is the first step into building an actual smart speaker. In this part, I will explain how I built a custom PCBA for the local voice assistant. Just a short disclaimer, I am not an electronics or PCB design expert. I'm a hobbyist and this is the first time I design a fully assembled PCB. So if you are an expert or you have more know-how than I have and you identify errors or optimization potential, then please let me know in the comments or contact me via direct message. I will really appreciate it. Thank you. But now let's get started with this. The first thing I did was to build the circuitry. Here you can see the circuit diagram. It's a little more complex because I rebuilt the whole ESP32 circuit as well. But everything you can see is kind of based on the reference architecture by the different manufacturers. For example, for the ESP32 circuit, I basically used the reference architecture from Espressif. So you can see different components here. First of all, of course, this is the microcontroller, this is the ESP32, which has all the different GPIO outputs and etc. and all the control inputs as well as also the power source. Then you have the buttons. We have a reset button as well as the boot and user button, which can also be used for user interactions. Then we have the USB connector here, which also gives us the power for the whole PCB. And then we have the USB to UART interface, which then connects the UART interface to the ESP32. We also have a power input selector. This allows us to define whether we want to power the whole PCB via the USB connector or whether we want to power it directly via a pin that is an input to the ESP32 module. We also have a converter from 5 volts to 3.3 volts because the ESP32 needs the 3.3 volts. We have the power LED, which is green. So this power LED shows whether the device is powered on or not. And we have a user LED, which is in orange color. So this LED allows us to display different states, for example. I will use this in a first step to indicate whether the wake word for the voice assist was detected or not. Then further on we also have our microphone. This is the INMP 441 MEMS microphone. You already know that from our first part of the series. This is just some headers where this microphone can be plugged in. We have the MAX 98357A amplifier, which is required to drive the speakers. This is also the kind of reference architecture that I just used here. We have some further serial signal handling for the UART, etc. And then we have some connectors, which allow us to still be able to just directly connect to the GPIOs of the ESP32. Because if I wouldn't have these connectors, I would have no chance for kind of debugging and also plugging in additional sensors, modules, etc. This is basically the circuit diagram. So once we have finished our circuitry, we can place all the components on a PCB layout. Here you can see that I have decided for a round PCB because I want to build a round smart speaker, like for example an Amazon Echo device. I also placed some holes for screws where you can attach it to a certain housing. And then we can go through the different components. We have our USB connector, which is later also used for powering the device. We have the ESP32 microcontroller as the heart of the architecture. We have some pin headers that allow us to get into the GPIOs. Also, it allows us to get 3V3 power and ground signal. Here we have our USB to UART converter. We have the user buttons, or the buttons. We have the LEDs. This is the power LED, this is the user LED that we can use for some status information. We have this jumper here, which allows us to switch whether we want to power the device via USB or whether we want to use a pin on the pin header, which is this one here. You can see 5V external. Then we have these pin headers here for the INMP441 microphone. The idea is that you can directly plug in the microphone here if you want. This is the Max 98357A amplifier, and here we have our speaker outputs. That's basically it. And now we can also have a look at our PCBA in the 3D view, as you can see here. Basically the same components that we had seen already before, so I don't want to explain them again. But you can see that this PCB looks really nice, at least from my point of view. I hope you like it as well. But bear in mind, this is just the first revision, and once I will test this, I will probably find some issues that I need to fix, because I'm not an expert for PCB layouting and PCB design. It took a while for the PCBA to arrive, but it finally arrived. And this is how it looks like. Looks very good from my point of view. So I started testing it. So this is the very first revision of this PCBA, and I was really worried that it would even start up. But it did. As soon as I plugged in a USB cable, the power LED lit up, and this was a very good sign from my point of view. But of course, there were some bugs or problems. So the first problem that I identified is that the port for the INMP441 microphone is flipped around. So that means it is not possible to correctly wire the INMP441 microphone by just plugging it in. I had to go and use some jumper wires to make sure that it is connected correctly to the PCBA. This should be changed for the next iteration of this PCBA, so that I would be able to directly plug in the microphone here with no additional wires required. The second problem I identified is more complex. You know, my idea was to add this NeoPixel LED circle in order to give some status information on the voice assistant. For example, it should light up when the wake word is detected, like the Amazon Alexa does. It should also give you some status information that it's working, etc. But as soon as I plug it in, and I plugged it in correctly like I did in the prototype, I thought, it does not work as intended. Because whenever the voice assistant is speaking, so whenever there is output on the speaker, the NeoPixel LED circle is turned on unintentionally. It was not on purpose that it is turned on. And then after some seconds, I get a brownout error message on the ESP32, and the ESP32 restarts. The brownout message usually indicates that there is a voltage drop, which is too much of a voltage drop, so there is not enough voltage supply for the ESP32. I already tried some stuff. The first thing I tried was using a different GPIO for the data pin of the NeoPixel LED circle, because I thought maybe there is a signal interference from the speaker, because the speaker also draws some current and maybe it was interfering with the data line of the NeoPixel LED circle. But at least changing the GPIO didn't work. Also, I thought maybe I can power it differently, so I didn't power it via the ESP32, but I powered it directly from the USB port. This also didn't help. What I will also try now is to add a capacitor, so that the NeoPixel LED circle has a capacitor for buffering some energy. So because I think maybe whenever the NeoPixel gets activated, it pulls a lot of energy and it's too much energy for the system. So this could be also an issue. But there will be also some further things. And if you have an idea what could be this problem here, then please let me know in the comments. Thank you. So this was part 2 of my video series on how I built a local voice assistant based upon ESPHome and Home Assistant. The next video will be about the housing. So I will design a nice housing and I will 3D print it and assemble everything together. If you like this video, then please subscribe to my channel to support me and also hit the bell in order to get notified about my upcoming videos. And I will now show you once more how my current prototype of the local voice assistant works. See you next time. Bye bye. Alexa, turn on smart clock.
Turned on the switch.
Alexa, turn off smart clock.
Turned off the switch.